yell at us to shut up.
All right, guys, so we're going to start Chapter 12. It's costing energy, and there's also a question on one of the exams. So if you had other questions on the exam, save those up, and we'll do that in the middle third here. But let's get into costing energy. Let's get into the page here. All right, so the first figure here in the book, kind of everybody's favorite topic. What does gasoline cost? So right off the bat, let's just throw a little bit of math out there. I'll give you a couple minutes by now. You should be pros at this. Tell me, yeah, you should. Tell me what the cost of fuel is in dollars per gallon. And let's just do the fuel price right now at 50 pence per liter. And here's I'll give you some numbers to throw in. 50 pence per liter. But let's just say 1 pound equals $1.5. Let's do it that way. And I think you can do the math on that. So cents to pence is the same ratio. And then 1 liter, or no, let's do it this way, 1 gallon equals 3.8 liters. So here's your volume. Here's your money. Ready, set, go. Okay, so what I asked you to do was just take the fuel price in the U.S., and you also hear this is kind of a telling slide because a lot of times you hear people complain about the high price of fuel in the U.S., but if you look at these other countries, it's half to maybe even a third.
I want it to be higher.
Well, there are those as well. So, and the reason we just see these pump prices for India and China is just that it's not that there's not a tax, it's just not known or not published. So let's go ahead and figure what this is in dollars per gallon. So we kept the math relatively simple.
You're not up.
Oh, share my screen, thanks. Top secret information. So here's what the answer looks like. So I started off with the problem, and there we were at 50 pence per liter. And what I did, I used lowercase p to represent pence. I used uppercase L to represent liters. And then I extrapolated here and said that if I know 1 pound, is there a couple slashes through that somehow? Or I want to say there's some other, like this, 1 pound. I think it's something like that. 1 pound equal.
I thought it was a liter earlier because I do big cursive L.
Oh, yeah.
For liters.
Oh, okay, yeah. For liters, I usually use either a big L or sometimes a lowercase script. Yeah, cursive, it's nice. So 1 pound sterling, I just said, is $1.5. Just to run through this as a exercise. So 1.5 cents would be the same as 1 pence. And then to get from cents to dollars, I know that there are 100 cents in $1. And then finally, I need to do my volume conversion. So I've got liters here in the denominator. I've got to get rid of it so it's over here in the numerator. And now I can go through and say my pence cancel, my cents cancel, the liters cancel, and then I'm just going to be left with
Dollars per gallon.
exactly. There's your dollars, and there's your gallons. So at this point, we're ready for the calculator. So 50 times
Wouldn't that be 0.5?
1.5. Well, it's 50 pence.
So, but wouldn't you, technically, wouldn't that be 0.5?
It would be 0.5 pounds, but I used pence. I mean, if I had pounds up, and you could have done it a different way. You could have said, hey, I'm just going to use pounds and we can run that number too. But yeah, if you had a pound here instead of a pence, it would be 0.5. But since I use pence, I had to use 50. So that's how the units and the numbers play off of each other. Absolutely, yeah. In fact, while y'all were working my problem, I made the same mistake. I put 0.5 pence, but it's not 0.5 pence, it's 50 pence. Yeah. 0.5 pounds. So 50 times 1.5 times 3.8 equals 285 divided by 100. Oops.
$2.25.
Yeah, 285.
You want to hear how I got there?
Sure.
It's really cool, actually.
Okay.
So when I asked you how many pence per pound,
Yeah.
it's like 100 for one, right?
Yeah.
So I did 50 pence for every liter
Yep.
times a pound for every 100.
Yep.
And then I did $1.5 for every pound.
Right.
So I did the
Sure.
conversion between pence and pounds.
Yeah.
To get there, and I got the same exact answer. And
Yeah.
I multiplied it by 3.8 liters per gallon.
Perfect.
Pretty
Perfect.
cool.
Yeah. Yeah, so I didn't have the pound to dollar conversion in there, but
Yeah.
if you
that's
did,
fun.
yeah, works out. Perfect.
I got it for that reason.
Yeah.
Since 50 pence is half of a pound, and 1 pound equals $1.50 American, I just
Oh, wow.
half the $1.50 to match the liter value.
Yeah.
That's 75 cents, and I multiplied 3.8 liters by 75 cents and got $2.78 per gallon.
Super,
That's cool.
super.
Yeah, that's actually
That's
pretty
master,
cool, dude.
yeah.
I think Tyler actually used atomic mass units and octane, but no.
Getting crazy up here.
All right, cool. All right. So, I mean, you look at this, you look at this previous slide, and this is obviously liquid fuel. This next one, this is electricity. So what we're looking at here is comparative domestic fuel prices. This is 2009. So again, we have very little to complain about in terms of what our energy costs actually are. And you can, make, I don't know, extrapolations, guesses as to why this must be. If you were running a generator in, let's say, Antarctica, the same energy is going to cost you even more. It's just, it's how far you are from these different sources. I don't know exactly why electricity is so expensive in Denmark. I know that a lot of their electricity comes from wind, and I don't know exactly what their storage looks like there, if they're doing, pumped hydro or battery, but that can tend to drive prices up. The UK, a lot of this is actually bundled into what it costs to go find new energy. So if they're like, hey, we're going to have to go and invest in offshore wind, or if we're going to do some tidal, a lot of times that price ends up going into the bottom line. It is worth noting, though, and this is kind of a neat thing about it. The electricity, all of those blue lines are longer than the red ones and the green ones. Why is that? Give me a guess. Why would electricity? It's all energy, right? Why would it be more expensive? Yeah, Cap.
I'm assuming because we use more of it, it's been higher demand, so they can charge a higher price for it because it's just more necessary. We use it for more.
Okay, so supply and demand, that's one hypothesis. Any others?
Just the fact of how we actually have to make electricity versus getting gas.
Mm-hmm.
Just gonna say that.
Yeah, that's closer to the answer. I think the fact of the matter is, yeah, we need electricity, keep the lights on, keep the MRI machines running, all that good stuff. But I don't think it's necessarily that, and yeah, there's some supply and demand there, but,
Because of the infrastructure maintenance and like how
yeah, it is.
expensive of a system
It is.
is.
Right, it goes through a lot more, so the heating oil, I mean, you're out there, you've got your pumps, you put in the tanker, put in the pipeline, and here it comes, and you set it on fire. Pretty old school. Same thing with the gas, pull it out of the ground, put it in the pipe, you set it on fire. Fairly simple, straightforward. The electricity,
There's multiple steps to
a
get.
lot going on there. Yeah, it's either coming through, and it's coming from multiple sources.
Hydro.
Typically, and not always thermal, but the majority of this, as we know, are going to be thermal plants, either coal or gas or nuclear. And now you've got your turbine spinning. You've got a lot of maintenance on these things. So that's the reason. And this is also why, if you're trying to decide what's the best heating system for my house or the best cooking system for my house on a per dollar basis, you kind of want to stay away from electricity.
It's also because they haven't privatized their energy market. They're based on a municipal basis.
Denmark?
Declaration. Yeah. I just read it in here.
Cool. Well, thanks. Thanks for that. So privatization wins the day. Okay, cool. Thank you.
In a lot of ways.
Nice.
But you can just see it as a taxation, a nationalist taxation.
Right. Okay, so now we're looking at the price, and this is pounds per gigajoules. And again, we've got electricity, right there at the top. Light fuel oil is more expensive. Heavy fuel oil, burns dirtier, less expensive yet. Gas, and then poor old coal is sitting right down there at the bottom. So, in a lot of senses, you'd say, well, gosh, let's just do coal all day long because it's so cheap. Well, as we're finding now with the ash ponds and the cooling and the scrubbers and all that, it's gone up considerably. Yeah.
Isn't there newer coal plants though that can get more out of it, more return? That there's a possibility, because I heard there's like new generation coal power plants, especially China's.
Yeah, there are.
Does that mean no?
There are, but if you run it back to Chapter 4, I think if you remember, every single coal plant is always governed by Carnot's law. I mean, you still, there's and every material where you're burning coal has a melting temperature. It's only so hot you can get. Also, the hotter they get, the more NOx, the more oxygen is actually combining with nitrogen, which you don't want because you're wasting that energy. You want that oxygen to combine with carbon in order to make energy. So, yeah, but and if you remember the paper out of Italy, the efficiency we were talking, they're right up against that. I mean, they're eking out halves of percentages. So, yeah, but again, you're really knocking on the laws of physics here rather than just like a technological breakthrough. So, at least that's my interpretation. Okay. And then, a lot of it's also due to import prices. Okay, so that's all relatively easy to understand. This next stuff, well, that should be relatively easy to understand. I mean, we all go to the grocery store, buy food. We kind of know what a gallon of milk, loaf of bread, jar of mustard costs. But this is this is not so much. This is kind of more difficult to wrap one's head around. So what we're looking at right here, this is a change in the retail price index. And I'm just going to read this from the book so we're all on the same page. The retail price index, RPI, is an economic indicator that specifically addresses the prices of a representative mixture of typical household goods. Hypothetical basket we just saw of goods at a point in time. It says the UK has recently changed to a consumer price index that specifically excludes any interest payments such as on mortgages, but that doesn't really affect the process described here. So I'll keep reading. Indices such as these are usually expressed as being equal to 100 in a specific base year. So here we are on figure 12.5. Shows a plot of the UK retail price index from 1950 to to 1910 with 2010 with 2010 as the base year. From the figure, it can be seen that the goods that would have cost 100 pounds in that year could have been purchased for only 30 in 1980 and only 3.75 in 1950. So let's just go back here. Let's just say that cost you $100. I mean, that'd be a pretty expensive. Maybe you're out at Whole Foods or a good food store or whatever. There's a $100 basket of groceries.
Definitely cut out the condiments.
Yeah. Yeah. I don't know, maybe there's some chocolate bars or some almonds at the bottom. But the point is, it would have cost you 3% in those dollars that many years ago. So if we look at this next figure,
Is that indicative of the war right there, the price, the percent of inflation?
It's all post-war.
which war?
Vietnam?
No.
Was this for the
70s?
US?
This is this is the UK. This is the UK.
Oh, okay.
Yeah, yeah.
I didn't know that. I was-
No, yeah. Okay, now the next one, I'm going to read this next one, so that's the plot on the right. It says, inflation is usually described as being the rate of change of the retail price index per year. Mathematically speaking, this is the slope of the RPI time chart and is shown in 12.5. Okay, the period of high inflation between 1973, right there, and 1984, right there, can clearly be seen. So let's just look at this from a mathematical standpoint and compare these two charts, because it's essentially the same information, just plotted in two different ways. Okay, I'm not going to be too picky about the actual numbers here. I'm just going to show you the shapes. So here was your RPI, retail price index, and here is your inflation. So, first of all, inflation is at least in this chart, always positive. Doesn't have to be, but it just means that things are going to cost more in the future in terms of dollars. Now, what drives that?
More demand.
More demand drives it. What else?
How far it goes, transportation.
Well, how far it goes, what else?
Supply.
Supply. The other thing that drives it is just the fact that when somebody lends you money, they're going to want more money back in the future. It's just the nature of money. That's it's the way it is. Because like if I had money, why would I just give it to you and not want any back? Because now I can't, literally, if I'm a bank, now I don't have my money anymore. I can't make my money work for me. That's how banks survive. They give you some money now and they want more back later. So the point is, there always has to be more money in the future. Kind of weird, but that's why this number is always greater than zero. Now, you hear about, China manipulating their markets and deflate, and it's happening in Japan. It's kind of weird, but, that's for the economics, the large economics firm to deal with. But the point that I want to make is that when this slope is high, so if we just call this, this is delta T, yeah, and we'll just call this delta R, that's somewhere up here, it's high. And when this delta T over delta R is lower, it's down here. So all the funny little bumps and curves in that chart on the left are what's dictating the value on the right. Now, pop quiz.
Sure.
Knowing what you know about power and energy, which one of these looks like power and which one looks like energy? If you had to make an analogy.
Power would be the RPI, energy would be the inflation.
I think it's the other way around. Yeah, it's the other way around. Yeah, it's okay. This is going to be power, and this is going to be energy. So this is why power and energy are a fantastic analogy for a lot of things. Because, and I'll show you why. Because, and we can go all the way back before, and we can even think of our power bill. So, you know, let's just start at midnight. Heard a few people say they're up past midnight, so you probably did have the lights on. Oh, at midnight, here's 6 a.m., here's noon, here's 6 p.m., and here's midnight again. So typically, you know, during the day, your energy demand looks something like this. This is kind of the, you know, the graph. All of this stuff under here is the energy, because that's what you're paying for on your power bill. But each little point, the value, you know, where you are here, where you are here, where you are here, that's the actual power. You know, maybe this is, you know, 2 kilowatts, et cetera. So hopefully that that makes sense, because power is actually the slope. So inflation equals the change in the RPI as a function of time, and we also know that power equals the change in energy as a function of time. So that's how those two are related. So now you kind of have a, you know, there's money, there's energy as a function of time. One thing to consider is whether or not there will always be more energy in the future. Because we know from the first law that it's a fixed finite amount. And you can't really ever kill it. You can only degrade it or concentrate it or deconcentrate it. That's really all you can ever do with energy. You're never going to kill it. It's always going to be there in one form or another. The best you can do is disperse it or concentrate it. Same thing's kind of true of money. You just, you know, give it away and stick it in the bank.
Print more.
Yeah, well, the point of printing more is that, you know, now things are going to cost more because there's just more money to fly around. All right, good. And that is not easy to wrap your head around. And I'm not sure I explained it all that well, but I mean, it's taken me, and I haven't been thinking about it that long, but it's taken me most of my adult life to figure that thing out, at least be able to talk about it intelligently.
We'll have to wrap you up like a mummy and seal you in a tomb.
Okay.